Hi everyone, good morning first of all, and welcome back to my channel. Good morning because right now it's 5 a.m. in India, and I woke up early just to make my YouTube video, just to make a video on a very important topic that I was thinking of making it on, which is trigonometry, class 10th trigonometry. I have taken 10 most important questions, proof questions you can say, and some solving questions too, which we are going to do it in today's video. So yes, let's get started quickly. I'm going to share the screen and we are going to start with the first question. So I hope you can see the screen and you can see the first question over here where we have to prove that 1 plus tan square A upon 1 plus cot square A will be equal to tan square A, right? So, in the proofs, we normally starts either with the LHS and we reach towards and we bring the RHS, or we start with the RHS and bring the LHS. Here, taking the LHS is, of course, like a better choice. So we are going to start with the LHS. And on the LHS, we have 1 plus tan square A upon 1 plus cot square. Now, here I want to tell you one thing that when you're solving trigonometry questions, your formulas in the trigonometry that should be very clear. I have made videos on trigonometry previously as well, where I have talked about formulas too. So if you just watch the playlist of class 10 important questions, you can just explore my channel and you will be getting videos. I'm not going to put the link for the very first time in the description box because I want you to go and explore my channel and see what are the extra topics that are available on my channel. So please go on. Okay. So how are we going to move ahead here? We have a very famous trigonometric identity that is called sec square A minus tan square A equals 1. So from here, I can write down sec square A is equal to 1 plus tan square A. It's very important in mathematics whenever you are using any formula, you write it on the side because others can understand that what formula have you used. So 1 plus tan square A, we have sec square A. So I can write down here sec square A upon. Next, there is another formula which is cosec square A minus cot square A equals 1. So from here we can write down cosec square A equals 1 plus cot square A. So we have a formula for the denominator as well. 1 plus cot square A is nothing but cosec square A. So I can write down cosec square A. Now we know that sec and cosec, sec is nothing but it's the reciprocal of cos. And cosec is nothing but it's the reciprocal of sine. So using this formula, can I write down sec square A as 1 upon cos square A? And for this cosec square A, which is actually 1 upon cosec square A, that will become sine square A, right? Now we know another formula, and that is sine A upon, or sine theta, you can say sine A upon cos A is nothing but tan A. So using this formula, this will become sine square A upon cos square A tan square A. And you can see this is what we wanted to prove. This is our RHS, hence proved. So if you can notice, I have solved this proof question by using these formulas, which I have written on the side. So you can also write on the side. We are done. So this is the first question. Let's go to the second question now. In the second question, it is given sine A equals 3 by 5. And we have to find out the value of cos A and tan A. So I want to tell you to find out this. We have multiple ways, right? I'm going to use the most simplest one, which I feel like using it, which is the formula, right? And the formula is, we know a very famous trigonometric identity that sine square A plus cos square A equals 1. Using this formula, if I just write down this here, sine square A plus cos square A equals 1, And here sine A is given 3 by 5. So sine square A will become 3 by 5 square plus cos square A we need to find out equals 1. So this will become 9 over 25 plus cos square A equals 1. So cos square A will become 1 minus 9 by 25, which is cos square A is, if you take LCM here, 25 minus 9, which is 16 by 25. So what will cos A become? Square root of 16 by 25, which is 4 by 5. So we have got the answer. That is what we wanted to find, cos A. So we got cos A. Now we have to find out tan A. Here again, tan A, I can directly use the formula because we know that we can write down. Since tan theta is sin theta upon cos theta, you write down the formula as many times as possible when you are solving the questions, because that is also going to be useful to for you to remember these formulas. Okay, so keep writing. So using this formula, this will become tan A is sin A upon cos A. Now we already have the value for sin A, which is 3 by 5. And for cos A, we have got 4 by 5. So we have 3 by 5 divided by 4 by 5. If you simplify this, it will become 3 by 5 times 5 by 4. 5 will get cancelled and 3 by 4. I'm so sorry for my voice. It's morning time. I woke up early just to make this video because I'm not getting time to make the YouTube videos because I'm having other classes. So that's why today I decided that I'll wake up early and I'll make the video for all of you. And there you go. Tan A equals 3 by 4. That's it. We wanted to find out the value of cos A and tan A, and there we go. We are done with this. Now we can go to the third question. The third question is we have to find out the value of, it says just find the value. I'm writing only find sin 60 dot means here times, okay, cos 30 degree plus sin 30 degree cos 60 degree upon cos 0 degree. So whenever we see 0 in the bottom, we just do not feel good about it, like, because anything upon 0 is, as you know, infinity, undefined. But here it is not upon 0. Here it is cos 0. And we have the values for all these angles. So let us first write down all the values. Science, we can directly put the values. Okay, you don't need to write down this again because we are going to do the same thing. So the value of sin 60 is root 3 by 2. So sorry. The value of sin 60 is root 3 by 2 times the value of cos 30 is also root 3 by 2. Okay. If you want to know how to remember these formulas in a very tricky way, because I still remember the formulas in that way, you can let me know in the comment box. I'll make a separate video just to make you remember the formula. The value of sin 30 is half, and the value of cos 60 is also half. And upon cos 0, the value of cos 0 is 1. Now we can write down this as root 3 into root 3 will become 3 upon 2 into 2 is 4. So 3 by 4 plus 1 into 1 is 1 upon 2 into 2 is 4. And upon 1, we don't need to write down because you know that any number divided by 1 is the same number. So we can skip writing the 1 now. This will become 4 by 4, which is nothing but 1. It was very simple. We are done with this as well. Question number 3. Now we'll go to question number 4. Remember, this is the first part of taking trigonometry questions. You can say this is a 10 basic trigonometry questions that I have taken. In the next video, I can take the medium level, and then I'll make another video, 3 parts of this video, and in that I'll be taking the advanced questions. All right, we can go to the next question. The next question is if cos A. Oh, I'm so sorry. Don't think that I'm I'm sleepy. No, I'm not feeling sleepy at all. It's just the one note is not supporting properly. If cos A equals 5 by 13, find the value of sine 2A. Again, to solve a question in trigonometry, there can be multiple ways, right? So I'm going to use my favorite way here. If you see any other way, that is also okay. Your answer should come the same. That's it. So to find out the value of sine 2A, there is a formula. And the formula is for sine 2A. As soon as I look at sine 2A, all I can think about is 2 sine A cos A using the formula. So if this is 2 sine A cos A, using this formula, I can write down here sine 2A is 2 sine A cos A. Now in this, we have 2 into sine A value we do not have, but cos A is given, which is 5 by 30. But we know that from cos, we can find out the value of sine. Why? Because the formula sine square A plus cos square A equals 1. So sine square A, 5 by 13 square, which is 25 by 169 equals 1. So this will become sine square A equals 1. I'm just finding the value of sine A so that I can put it. 1 minus 25 over 169. And if you just take LCM, it will become 169 minus 25 over 169. And this will become 144 upon 169. This is the value of sine square A. We have to find out the value of sine A. So this will become 12 over 13. That's it. So 12 over 13, which is the value of sine A. So we can put it here, 12 over 13. And therefore, the value of sine 2A, we are getting 2 times 12, 24, 24 times 5, 60, and 13 times 13, 169. And that's the answer. We cannot simplify this further, so that's why 60 over 169. We'll go to the next question, question number 5. After this, 5 more questions left because this video is all about doing 10 questions. The next question is tan A is given 3 by 4. Find sin A plus cos A upon sin A minus cos A. Now this question I'm going to solve it in a different way. Unlike the other ones I was directly solving using the trigonometric identities that I know. This one, let's solve it using the Pythagoras theorem. Okay. The first thing that I remember I had learned in trigonometry to solve the questions using the Pythagoras theorem only. So first of all, tan A is 3 by 4. There is a formula for tan theta, which is P by V. P by V, that means perpendicular upon base. So here we have tan A 3 by 4. So I can take the ratios as 3k and 4k, 3x and 4x. I'm directly taking it, okay, 3 by 4. Using Pythagoras theorem, we know that hypotenuse square is equal to perpendicular square plus base square. Hypotenuse we have to find out because we don't have this. Perpendicular is 3 square, base is 4 square, which is 9 plus 16, which is 25. So h square is 25, that means h is 5, right? So we have all the three things. We have P3, we have B4, and we have H5. Now we can solve this. What will be sine A? The formula for sine theta, you can write off because we know the formula of sine theta is P by H. So using this formula, it will become P, that means 3, H means 5. And cos theta, that means cos A. Cos theta formula is B by H. So what is B? 4. And what is H? 5. So we have all the values now, sine A and cos A, and we have to just substitute here and we'll get the answer. So therefore, 3 by 5 plus cos A, 4 by 5 upon sine A, that means 3 by 5 minus 4 by 5. So if you simplify the top part, it is 3 plus 4 by 5. And if you simplify the bottom part, it is 3 minus 4 by 5. That is nothing but 7 over 5 divided by minus 1 over 5, right? So if you simplify it, 7 by 5 times minus, you can say 5 over minus 1. 5 over minus 1. So 5 will get cancelled and it is minus 7. I hope there is no doubt in the calculation part. That's a very basic calculation that I have done. But still, if you feel like while watching my videos, if you have any doubts, please do let me know in the comment section. I read every comments that I get on my YouTube channel. So I will be very much optimistic about it. And you can just let me know, give me your feedbacks, whatever you feel like. Okay, so this was our question number 5. Now we can go to question number 6. Question number 6 is a proof question where we have to prove cos square A upon 1 minus sin A plus cos square A upon 1 plus sin A equals 2. This is what we have to prove. Now here to solve this, first I can clearly see that cos square A is in both the terms. I'm going to start from the LHS. So in LHS we have, I'm just rewriting the same thing, cos square A upon 1 minus sin A plus cos square A upon 1 minus sin A. Here I'm going to take the cos square A common first. So if I take cos square A common, inside I have 1 upon 1 minus sin A plus 1 upon 1 minus sin A. I'm so sorry, it's plus here. So plus sin A. After this, what I'm going to do, I'm going to simplify the bracket part. So this is cos square A as it is. Inside the bracket, I'm going to take LCM, which is 1 minus sin A times 1 plus sin A in the denominator will get. And in the top part, of course, it's like an LCM only. So on the top, we'll have 1 into 1 plus sin A, so 1 plus sin A. And here we already have 1 plus sin A, so 1 into 1 minus sin A, which is 1 minus sin A. Here plus sin A minus sin A will get cancelled. So what we are getting is cos square A into 1 plus 1 is 2 upon. Here in the bottom part, you are getting one formula, which is actually A minus B into A plus B. So A minus B into A plus B is A square minus B square. So using this formula, it will become A square, that means 1 square, which is 1, minus B square, that is sine square A. Now this will become cos square A into 2 upon. Again, here we can use the formula, a formula that I was using even in the previous questions, which is cos square theta plus, or you can say cos square A plus sine square A equals 1. So from here, cos square A is nothing but 1 minus sine square A. So for 1 minus sine square A, we can use cos square A. So I can write on cos square A here. This and this will get cancelled and this is 2. This is what we wanted to prove. This is our RHS, hence proved. So we are done with the 6th question as well. Now we are going to the 7th question. Just going to make it a little bigger. Question number 7. In question number 7, we have to evaluate, or you can say we have to solve. So what do we have to evaluate here? 1 plus cos 2a. This is very simple actually. 1 plus cos 2a upon sine square a. If a is given 30 degree. So we have to find out the value for this, right? So we can write down this as 1 plus cos 2a is 30. So 2 into 30. And in the bottom we have 1, sine square a. So sine square a is 30. So 30 here. Now we can write down this as 1 plus cos 2 times 30 is cos 60 upon sine square 30 as it is. Now we'll simply put the values of these angles. Cos 60, the value is 1 by 2. And sine 30, the value is 1 by 2. But because it's a square, so it is going to get squared. So this will become, if you take LCM in the top, it will become 3 by 2 over, this will become 1 over 4. If you simplify this, it is 3 by 2 divided by 1 by 4, right? And the next step, 3 by 2, division sign will become multiplication sign. Reciprocal of 1 by 4 is 4 by 1. So simply this will become 6, and that's the answer. We had to evaluate this, and the answer that we have got is 6. And this was our question number 7. 3 more questions we have to do. Let's do it. Question number 8. Question number 8 is again a proof. We have to prove that 1 minus cos square A upon cot square A equals sine square A times tan square A. So we have to prove this, right? Again, here we are going to start with something that we already know. And for that, I'm just going to write down the LHS first. On the LHS, we have 1 minus cos square A upon cot square A. I can write down 1 minus cos square A as sine square A. The same formula here, which I have used, this one. I'm directly writing, but you can, of course, write down this formula in your exam. So 1 minus cos square A will become sine square A upon cot square A. I'm writing as it is. Now I can write down sine square A. I'm so sorry. This is not cos square. This is cot square A. Cot square A. Now this is very simple actually. Can I write down this as sine square A into 1 upon cot square A? We can write it down, right? After this, I can use a formula. Tan and cot are reciprocals to each other. So tan theta is 1 upon cot theta. So if we have 1 upon cot square A, we can use this formula and we can write down tan square A. If you notice, this is nothing but your RHS, hence proved already. Done. That's the most beautiful part when you just get the RHS. All right, this was question number 8. Now we'll go to question number 9. In question number 9, it's again a proof. We have to prove that tan A plus cot A upon cos sec A. Sec A plus cosec A equals sin A upon cos A. Here I would give you one advice. To prove this one, you convert everything that is there on the LHS in the form of, or you can say in terms of sine and cos only. That's how you'll get the answer, because on the RHS you have the answer in the sine and cos form, right? So let's start with the proof. On the LHS, we have tan A plus cot A upon sec A plus cosec A. And here we are going to use the formulas. The formulas like tan theta is sine theta upon cos theta. I'm directly writing all the formulas here. Cot theta is exactly the opposite. That means cos theta upon sine theta. Sec theta is 1 upon cos theta. And cosec theta is 1 upon sine theta. Now using this, I can write down tan theta as sine theta upon cos theta. I mean sine A upon cos A, because the angles here are A. Cot A will become cos A upon sine A. In the bottom, we can write down sec A as 1 upon cos A. And cosec A we can write down as 1 upon sine A. Now I'm going to solve the top part. So to solve the top part, I'm going to take LCM. So it will become cos A sine A. So here the cos A is present. Sine A will get multiplied with the sine A to make it sine square A. And here it will become sine A present. So cos A into cos A will become cos square A. In the bottom, I'm again going to take the LCM. So that will become cos A Sin A. I hope there is no confusion in this part because I'm just solving the top part and bottom part. Take the LCM, so this will become sin A plus cos A. Right, so we have got here this. Now can we not write down this as sin square A plus cos square A? That is 1 because of the trigonometric identity. So 1 upon cos A sin A and then divided by this term. So divided by sin A plus cos A upon cos A sin A, right? Okay, so now we have got here, if you simplify this, 1 upon cos A into cos A sin A upon sin A plus cos A. So here clearly this and this will get cancelled. So what we are getting is 1 upon sin A plus cos A. And because in the RHS, you can see here, we have to find out sin A plus cos A. Like we have to get sin A plus cos A. And here we have got 1 upon sin A plus cos A. So you can write down taking a reciprocal. I know that this is like a little weird, but yes, there is no other option. Taking a reciprocal, we have sin A. The reciprocal of 1 upon sin A plus cos A will become sin A plus cos A. And this is our RHS hence proved. Otherwise, actually, they should have given here tan A plus cot A upon sec A plus cosec A as 1 upon sin A plus cos. I'll consider this. Okay. Just, I'm just a bit skeptical about it, but I'm going to check it. Anyway, question number 8. This was 9th, the last question that we are going to do. So the last question is question number 10, which is we have to prove 1 plus tan square A upon sec square A equals 1. A very simple question here. So we are going to start from the LHS here. So on the LHS, we have 1 plus tan square A upon sec square. So here we can use the formula, formula that I had written earlier as well, which is sec square theta minus tan square theta is 1. So sec square A minus tan square A is 1. So here we can also write down sec square A is 1 plus tan square A. And sec square A, so at the place of 1 plus tan square A, we can use this formula. So it will become sec square A upon sec square A, which is nothing but 1, which is nothing but our RHS, hence proved. And with that, we are done with our video for today. So yes, 10 basic questions, level 1, you can say. In the next video, in the coming video, I'm going to make a part 2, level 2, in which there will be little advanced question. This was a very basic one that I had taken. So in that, I'm going to cover the trigonometry questions, and I hope you understood each and every question. If you have anything to say, do let me know in the comment section. I'm going to read every comments. Thank you so much, and see you in the next video. See you all super soon in my next video. Thank you. Bye.